Hey everybody, today we are talking about percents, continuing our learning on that. And so what we are going to be doing today, or by the end of this lesson, is that we are going to be able to set up the percent proportion. You're going to be able to find any percent of any number. And then we're going to be able to recognize the part, whole, and percent of any given situation. And so you'll see what that means more in a second. So let's start with an example. So we're finding percents of numbers. Diego starts with a 12-hour road trip with his phone battery charged at 75%. Given his normal usage, will his phone last the whole trip? And so we really have to look at this this picture here. And so over here, you can see his normal usage at 100%. If he has a full charge, his phone will last 15 hours. And so we're wondering if he'll have enough battery to last for 12 hours if he only has 75% left. And so what we're going to do is set up a percent proportion. Now, what is that? It is equivalent ratios. Equivalent ratios that looks like this. Part over the whole equals the percent over 100. So we set up two equivalent ratios. So taking a look here, we're looking for 75%. So the percent goes over 100. 100%, a full charge is 15 hours. And we're not going to put 12 right here because we're seeing if he'll have enough for 12. So we're trying to figure out how much, right, is 75% of the battery. So I'm going to fill in that variable with X. So we are done. We set up the percent proportion. We're looking for how many hours out of 15 is 75%, or 75 out of 100. Because if you remember from Monday, a percent is always a fraction out of 100. Now, we are going to solve this. The first thing I'm going to do is I'm going to convert my percent to a decimal. And if you remember how to do that, we just change it into 75 hundredths, or 0.75, as a decimal. Now, over here, what I'm going to do is, since this unknown amount of hours is being divided by 15, I'm going to do the opposite operation. I'm going to multiply by 15. And when we're working with equations, we have to do the same thing for both sides. And so what happens when I divide 15 by 15? Well, I'm just left with 1. So 15 divided by 15 is 1, and 1 times x is just going to be x. So I've isolated this variable. Now over here, now I have 0.75 times 15. Now, if you're thinking about back to Monday and Tuesday, this equation right here is exactly what we were doing on Monday and Tuesday. All right, when we were looking for 10% of a number, or 13% of a number, right? A lot of you found out we could just do like 0.13 times whatever the number was, like 24, right? So we just multiplied, which looks exactly like this equation. So that's where we get this equation, is from the percent proportion. This percent proportion is going to be very important to set up because we're going to be finding different parts in the future. So once we get here, we just multiply. Well, 0.75 times 15, we can just plug that straight into our calculator. And if you do that, you're going to get that it's 11.25. So that means 75% of the battery charge is 11.25 hours. Does he have enough to make the whole road trip of 12 hours? We can say, no, his battery will only last 11.25 hours. And we found that using that percent proportion. Let's try another one. Many people get confused and think that 100% is the highest you can go. That's not true. You can have above 100%. And a lot of people get confused on how to write it, but a percent is always a fraction out of 100. It doesn't matter how big it is. If it's bigger than 100, it's still out of 100. So this says a full set of adult teeth includes 160% as many teeth. That's bigger than 100. As a full set of baby teeth. How many teeth are there in a full set of adult teeth? I like to visualize. So 160% is greater than 100%. So I know my answer is going to be larger than 20. So if something is more than 100%, it's going to be more than the original number. I am still going to set up my percent proportion. Now, 100% of baby teeth, so we're talking about baby teeth, right? The whole amount of baby teeth is 20. So I'm going to put 20 as my whole. I'm looking for how many percent? 160%. So it's still a fraction over 100. And I'm looking for the amount of adult teeth. We can use t as a variable. That's what it says here, so might as well. We can use x, we can use any letter as a variable. I'm going to use t for teeth. So some people got confused as we were working through this today, and we were confused on how to convert 160% or 160 over 100 to a decimal. Well, we do the same thing as we would normally do, and that's we move it 2 decimal places. And if you don't remember, use your calculator as a tool. You guys all have it here. Fractions are just division. I can divide 160 divided by 100 just to double check, and it's 1.6. Some people were putting 0.16, which would be 16%. If it's bigger than 100%, 100% would be 1.00. So this is 1 and 60 hundredths. Okay, so we've got it as a decimal. Now we're going to multiply by this 20. Remember, we're multiplying by the whole, the total amount. So 20 divided by 20 is 1. So they go away. So t equals 1.6, and we still multiply by that 20. And if I do that, I would get t equals 32. What does it mean? How many teeth are in a full set of adult teeth? There are 32 teeth in an adult set. That's all that means. Does it make sense in my drawing? Yes, right? Because 20 baby teeth, 160 is going to be more, so I know it's going to be more than 20. 32 is more than 20. So going through, how would we do this ourselves without any of this given stuff, right? So here's just a question. A local Little League has a total of 60 players, 80% of whom are right-handed. How many right-handed players are there? So visualize drawing a quick bar sketch. This doesn't have to be the most perfect thing in the world, but how I do this is it just gives me an idea of where my answer is going to be. So when I see the word total, I'm thinking that's going to be my whole, that's going to be my 100%. So 100% of all the players, total of 60. 80% are right-handed. Well, thinking about what I know about percents, I know 50% is going to be here because it's exactly half. 80% is more than that, so my bar should probably come to about right here. So again, it's not perfect, but we're still using it as an idea of where. Now we can go back and think of our benchmark percents. 50% of 60 is half. So I know that my answer is going to be more than 30 and it's going to be less than 60. I'm still looking for 80% and I don't know that number, but I know about where it's going to be. So that's why I do that visualization. I know it's going to be between 30 and 60. Now I'm going to fill in my percent proportion. Part over whole. So total, the whole is 60. The percent over 100, that's 80. And I'm looking for players. So you can put P, you could put X, you could put R for right-handed. Doesn't matter. Just like I did before, I convert this to my decimal. 0.80, 80 hundredths. I'm going to multiply each side of my equation by the whole, the 60. 60 divided by 60 is 1. So 1 times P is just P. So the number of players equals 0.80 times 60. Just like we did 80% of 60, we're talking, we multiply the percent by the whole. When I solve, I just multiply. And if you did that in a calculator, you would get 48 players. Does it fall between 30 and 60? Yes, I'm checking. It makes sense. So all of this is what we worked on today. If you have questions, always email your teacher. You can ask. This is very important. So we're looking back at our first slide saying, can we set up that percent proportion? We can find any percent of any number by setting up that percent proportion. And then how we set it up is by recognizing the part, whole, and the percent of the situation. So that's what we're going to be working on for the next several days.